Hello, in today's video we're going to start a control systems lecture series, and we're talking about topics that deal with control systems. And a good place to start is an introduction to Laplace transforms. So this video is going to be very basic overview of what a Laplace transform is, and then we're going to do a few examples. So Laplace transform which is an integral transform. It converts a function of a real variable like t, which is time. So it's a real variable, right? That's time is a real thing, time goes on, to a function of a complex variable like s. So you'll see s a lot of times, and it's kind of confusing to start, but it's just another variable you can use that represents this S-plane, which is a complex plane in which Laplace transforms are graphed. So what a Laplace transform is taking it from the time domain to the frequency domain, which is also in the S-plane. And the S-plane is called the complex plane because it is broken up by this sigma plus I omega. So this is the imaginary part, and this is the real part. And if this was on a graph, we got the real part, which is this. So let's say this is 1. We have a point here. This is our point, and it's at 1, 1. So this is the imaginary, and this is the real. So S would equal 1 plus. It looks something like that. Nope, that would be a 1. I plus 1 plus I. So the S-plane is kind of difficult to wrap your head around, but you just kind of got to use it a lot. Alright, so now back to Laplace transform. So we have a function of f of t, but not all functions f of t are suitable to take a Laplace transform. The conditions for a suitable function is that we got to let f of t be a function of time t such that f of t equals 0 for t is less than 0. So we can't really have negative time. So when time is less than 0, the function of t is just 0. So if you were to draw this on a graph, so we have time t here, and this is some f of t, it needs to be 0 when t is less than 0. So finally, our equation that we use to find, by hand these Laplace transforms looks something like this. So we have our Laplace transform, known as L. We have our function f of t equals our function of s, because that's what we want. We want it in the S-plane, equals 0 to infinity. F of t e to the negative st dt. So we take our function of t, multiply it by e to the negative st, and then take the integral from 0 to infinity. Alright, so now we're going to go through some examples here. And we have about 4 examples that we're going to go through that kind of show how to do this math of taking the integral from 0 to infinity. I'm not going to go through all of them by hand. Well, I did already go through all of them by hand, so if you want to pause the video and look and see the math, you can. But I'm going to talk through quickly about each one. So here our function is e to the negative at. So multiply e to the negative at times e to the negative st. You can combine the numerators, take the integral of that. We have because integral negative, so then it's divided by negative a plus s. And then evaluate it from 0 to infinity. A couple things to know here that's important to know. E to the negative infinity is 0 because you think, E, because that just goes to 0. So that's e to the negative infinity is 0. Then we also have, remember, e to the 0 is 1, or anything to the 0 power is 1. So this just reduces to 1 divided by, a plus s. And also when you do these, just make sure you're keeping track. So I have a positive right here. Okay, that is it, because we have a minus here and then another minus. So it's like minus minus, and that equals plus. That's why that is plus. And when you're doing these by hand, if you see any of these in class, like they're all going to be pretty similar to these, because obviously to be able to take the integral easily by hand, there's kind of a small number of these that you can do. So we have e to the negative, and you get 1 over a plus s. Most commonly though, it's 1 over s plus a. So he's written with the s first and then plus your variable. Now our next example here, we have f of t equals a to the t. So for this one, we have to do integration by parts, which we can see here comes in this form. Did the math out there. Lots more math involved with this one. If you want to just look through this, pause it if you need to. I kind of accidentally, when I wrote this out, I was trying to skip a step, but this is, remember, e to the negative infinity. That reduces to 0. E to the negative infinity here. That reduces to 0. Then for this side, we have this negative a times 0, so that goes to 0. And then we have e to the 0, which reduces to just 1, so we have negative a over s squared. We have a over s squared. So the Laplace transform of f of t equals a to the t equals a over s squared. Another example here. I should have done this one first, but oh well. This is a simple one, just f of t equals a. As this equals a over s. So as you kind of see the difference there. So if you just have, so f of t equals a, the Laplace transform of that equals, or lowercase a over s. Then we have f of t equals at, Laplace transform of that is a over s squared. And you can kind of see the trend here. If we have f of t equals a t to the third, or a t, oh, I'm skipping here, a t squared, that equals a over s to the third. Now, the last example here, sort of different, but it's using the tools we already devised. We have a piecewise function. So we have f of t equals 2 from 0 to 2, and then f of t equals t from t greater than 2. Okay, so it looks something like that. Okay, but now we got to break this up from 0 to 2, and then 2 to infinity. And then just do the math. But remember, we don't have the infinity anymore or the 0, so we can't do some simplifications we were doing in the previous examples. So you kind of have to go through more diligently and do the math out, because we don't have those, again, simplifications we get from using zeros and infinities all the time. So I kind of just broke this up. So this is the math for this, and this is the math for this, for the second part. Let's see that there. Let's see that there. Then ultimately, you can just combine this and that, and we get that. So just a few examples. And in a future video, we'll talk about inverse Laplace transforms, and that's basically how we're going to go from, if we have this, and then we want to go to the time domain. So remember, just a quick recap here. Laplace transform goes from f of t to f of s. Time domain to the s domain.